guys, and welcome to this video in which I'm going to show you how to implement the linear regression in Eviews. So in this video we are going to show you how to analyze the impact of the advert revenue of a web page indicator that influence on the advert revenue of the web page. So we have a web page that earn a revenue function of the number of adverts that are viewed by the visitor of the page. So we have number of impression page views, we have number of click on adverts, the total revenue earned by owner of web page. So to run a linear regression by this for in Eviews, you just need to go on quick and then click on estimate equation. So when you click on estimate equation, we have a dependent variable which is the total revenue in euro constant, and the dependent variable that are the number of impression, page views, the number of views of the page, the number of clicks on adverts. So after selecting dependent variable and independent variable, we just need to click on OK, and the model has been estimated. You can see that the only variable that statistically influences the total revenue of the page is the number of clicks on adverts, because the p-value is less than 5%. So we have the R-square of 0.44%, and the adjusted R-square of 0.43. So the only variable that statistically significantly influence total revenue is the number of clicks on adverts. So as we have model our variable, if we are going to analyze our variable in terms of elasticity, we should apply the logarithm in our variable. So we apply the logarithm in our dependent variable log of the revenue. We will apply the logarithm on the number of impression. We will apply the logarithm in the number of page views. We will apply the logarithm in the number of clicks on video. So then click on OK, and we can see that number of impression according to the log model also influence significantly and the number of clicks. So as our model is set, we can analyze our model in terms of the elasticity. So the coefficient of log of number of clicks is 0.6564, meaning that when the number of clicks in adverts increase by 1%, the revenue of the page could increase by 0.64%. For the number of impression, when the number of advert impression increase by 1%, the number of the revenue increase by 0.3%. So we can look at residual diagnostic by clicking on view, and then click on residual diagnostic, and then click on histogram normality, for example, to see whether or not our residual are normally distributed. So then click on OK, normally distributed, and you can see that our error term are not normally distributed because the p-value is 0.000, meaning that we can just reject the null hypothesis, which is the normality of our residual, meaning that our model residual term are not normally distributed. So we are not happy about our model. So we can also check for heteroscedasticity of our model on view, residual diagnostic, and then click on heteroscedasticity test, and you can select by default the Brecht-Pagan-Gottfried test, and then click on OK, and you can see that the Fisher statistic of Brecht-Pagan-Gottfried test is 0.89%. It's 0.89, which is more than 5%, meaning that our error term are homoscedastic, meaning that we are happy about the homoscedasticity of our model. So we can also look at serial correlation in our error terms by clicking on going on view, residual diagnostic, serial correlation LM test. So click to include two lab in our equation, and then click on OK. So you can see that at 5% level, we can reject the null hypothesis of autocorrelation in our model, meaning that our error terms are not autocorrelated. So that's it for this video, and we hope we have helped you very well understand how to implement and interpret linear regression in Eviews.